I'm going to welcome everyone today. I'm Bob Margo. I'm the chair of the Department of Economics here, and this is one of the highlights of our academic year. It's the Robert W. Rosenthal Memorial Lecture. The lecture honors the memory of Bob Rosenthal, who was a member of the economics faculty at Boston University, who died unexpectedly of a heart attack at age 57 on February 27, 2002. Bob was one of the great economic theorists of post-World War II economics, responsible for many fundamental and profound insights into game theory and other aspects of economic theory. I never had the pleasure of having Bob as a colleague, but as it happens, I did know him because we served together on the NSF review panel. I witnessed firsthand how tough and forceful a critic he could be, how uncompromising his standards were. And this is on a committee where the average member comes from the dark side of the force, notorious for being a difficult group of people. At the same time, though, it was always very clear to me that he was extraordinarily generous with his advice and his counsel on how to improve a piece of research. His was never criticism of a personal nature, nor was it a form of blood sport so beloved in economics, but rather served to elevate the work under scrutiny because he was committed to the field as one of the great intellectual traditions and as a tool for understanding the world. We're grateful to the Rosenthal family and to the many friends in this room who have made this lecture possible through the generosity of their support. I have a short task today. It's to introduce the person who will introduce the speaker. The introduction is going to be given by Professor Jawad Noor. Jawad received his PhD in 2005 from the University of Rochester, where his thesis advisor was Larry Epstein, who, as we all know, is now, we're very pleased to say, a member of BU Economics. Indeed, one of the ways in which we honor the memory of Bob Rosenthal is to make sure that we have world-class theorists like Larry and quite a number of others that we have on our faculty. Jawad specializes on temptation, self-control, and other aspects of behavior that upset the pristine world of rational economics. His papers have appeared in the Journal of Economic Theory and Theoretical Economics, and he's the recipient of an NSF grant. He's also one of the very best teachers in the department, the recipient of a new Family Teaching Award. In his spare time, I'm not sure how assistant professors have spare time, but in his spare time, Jawad is devoted to South Asian classical music, as many of you know. He performs on the sitar. His website lists the musicians with whom he has studied. If you're a knowledgeable listener of this music, you will know immediately that he travels in very high musical circles. So I give you Jawad.
Thank you very much. I feel special. Okay, so I don't have too much time, so I'm going to be quick, brief, and super clear. So a quick overview of Douglas Gale's CV. So bachelor's in science and economics and math from Trent University, MA in economics from Carleton University, PhD in economics from Cambridge University. He's had positions as a junior research fellow at Cambridge, held positions at the London School of Economics. Came to the US in 1985, held positions at UPenn and University of Pittsburgh. Was part of our family, BU Economics, from 1990 to 96. He was instrumental in the renaissance of the department, and I'm sure all first-year PhD students are dying to know what course he taught. He taught 703. Dilip actually took over from Douglas. He then moved on to NYU, where he's been the co-director. Well, he served as the co-director of the CV Starr Center. He's been the chair of economics. He is currently a professor of economics and the Silver Professor of NYU. Time considered. So he has a long list of honors. That's all I'm going to say about the honors. He has a long list of professional activities, which include being associate editor at journals such as Review of Economic Studies, Econometrica, JET, and GEB. He's been the co-editor at Econometrica, Economic Theory, and currently is the co-editor at International Journal of Central Banking. He's got 5 books, one co-authored with Franklin Allen, edited other books. So let me now quickly turn to his research. So I'm going to talk a little bit about his research and basically keeping in mind the question of how exactly to categorize Douglas Gale. So let me first mention Frank Hahn, who was one of the leading researchers, along with others like Arrow and Radner, in the 60s and 70s, working in general equilibrium and extending it to incorporate finance and money, and more generally using it as a tool to provide micro-foundations for macroeconomics. This was a program that served as a response, the classical answer to Keynes. So Douglas was a student of Hahn at Cambridge, and much of his work has continued the program of providing micro-foundations for macroeconomic and financial phenomena. I'll now mention a very sparse selection of some of his work. In a 1985 paper in the Review of Economic Studies with Martin Hellwig, he asks, what are the micro-foundations for the standard debt contract? Why is it that firms have to pay back the entire loan, and if they can't, then they're going to be forced into bankruptcy? Well, he shows that in a very simple model, with asymmetric information between the firm and the bank can verify the state at only at a cost. The optimal incentive-compatible debt contract is in fact the standard debt contract. In a 1998 Journal of Finance paper with Franklin Allen titled Optimal Financial Crises, he writes a model of bank runs and tries to analyze its welfare properties. And he shows that, in fact, a banking system that's vulnerable to bank runs can actually achieve the first best allocation of risk and investment. Note that it's not possible to talk about the welfare properties of financial crises without first having some kind of micro-foundations for macro. In 1994 Econometrica paper with our very own Christophe Chambly, so they study a dynamic coordination game with incomplete information to understand dynamic investment behavior. So imagine that there's a recession. A firm is going to want to invest if all other firms are investing. A firm is not going to want to invest if no other firm is investing. They characterize the unique symmetric perfect Bayesian equilibrium and find that the equilibrium is in fact going to be inefficient because there are going to be delays and information is going to be imperfectly revealed. So in particular, when the time period is short, when you're close to continuous time, then it could be that there will be, then actually there's going to be a collapse of investment. Okay, so even if the state of the economy is good, and everyone has private information that the state of the economy is good, no one's going to invest. So these are examples of work which provide foundations, micro-foundations for macro and financial economics. He also has work on the foundations of general equilibrium. So in two Econometrica papers in 1986 and a JET 87 paper, he deals with the following question. So there were there was Rubinstein, Walensky, and others who showed that in a decentralized economy, where there's bargaining and search, if in some sense the frictions go to zero in the limit, they find that the economy does not in fact converge to a Walrasian equilibrium. All PhD students should be fainting right now because that seems to be saying that it's not necessarily the case that frictionless economies are Walrasian. But Douglas reaches a radically different conclusion under very general conditions using the same bargaining approach. He shows that every perfect equilibrium of the bargaining game implements a Walrasian equilibrium. So the upshot is that bargaining theory does not in fact undermine Walrasian theory, and in fact can provide a richer and more solid foundation for the theory of Walrasian equilibrium. So an introduction is going to be incomplete today without mentioning his JET 99 paper for two reasons. Firstly, it was co-authored with Bob Rosenthal. And secondly, it was perhaps the earliest sign that someday he would present a lecture with bounded rationality in its title. So Gale and Rosenthal asked whether boundedly rational agents who repeatedly play a symmetric game with a unique symmetric equilibrium will learn over time to play it. So they look at an example of where there's one experimenter and there and there are a number of imitators, and he shows that the two kinds of boundedly rational behaviors, they interact in very interesting ways and produce very complicated dynamics. One finding is that the interaction can produce endogenous cycles. This suggests that it might be one way to it might be a useful way of looking at certain kinds of macroeconomic fluctuations. Finally, in recent years, he has begun to do work in experimental economics. Seems like a bit of a break from the kind of work, the lines of research that he has been following, but in some way that's perhaps not so surprising. In my humble view, experimental economics, I think, is a very rich playground for economic theory. It's a rich playground for theorists who are interested not just in studying the property of models, but in fact, interested in looking at the world through the lens of models. So, empirically assessing a model requires a mapping from models into data, and theory is required at different levels. Theory is required first to determine what is the class of data that the model maps to. Theory is required to understand what is the mapping itself, and finally, and definitely not least, it's required to understand what is the data itself. Okay, and that's one place where theorizing about bounded rationality becomes very, very important. Because the data that we're going to get in experiments is never going to be ideal, in some sense. So I'm going to conclude with the question which I asked a little earlier. What category of economist does Douglas Gale belong to? Is he a general equilibrium theorist? Is he a game theorist? Is he a macroeconomist? Is he a financial economist? Is he an experimental economist? I don't think any one category fits him. I don't even think that the union of the categories fits him. From what I understand, I think he's an economic theorist who's just interested in understanding the world around him. Ladies and gentlemen, Douglas Gale.
Can't read this thing. Oh well, let's see if I can do this way. There we go. I have to use this to click it. There's no remote.
There's no, do you have a remote?
I'll just use the keypad. Well, thank you very much for that fulsome introduction and for inviting me here. It's very nice to be back at BU after so many years and to see Larry beaming at me, as always.
I'm not going to let you leave yet.
Well, we'll see. Anyway, what I'm going to talk about today is a research project I've been involved in for actually several years, longer than I care to admit. This is work that I've been doing with two colleagues, Shachar Kareev, who's an assistant professor at Berkeley, and Sinju Choi, who's a lecturer at University College London. And it began because we were interested in decision-making under uncertainty, and Shachar had come up with an idea for a new experimental economics platform, which I thought would be a natural for this kind of experiment. But we were quite unprepared for the results that we saw. The data that came out of it was so striking that we were sure something really interesting was going on. It's been a bit of a struggle to convince the economics profession, in particular the editors of economics profession, that we've got a smoking gun. In fact, Vince Crawford, who was until recently co-editor of the American Economic Association's lead journal, told us that he believed in us, but he thought the profession just wasn't ready. So I hope that you'll be a bit more accepting and open-minded. So what I'm going to do is begin by introducing you to that initial experiment and some of the results that came out of it. Basically, just try to get you comfortable with the data. And then I'm going to pose the question, which is actually in the title. Are we better off trying to interpret this behavior that we see in terms of non-standard preferences, that is, as a result of substantive rationality, but not satisfying the usual savage axioms? Or is something else going on? Is it a case of people using heuristics to maximize preferences that might well be of the standard expected utility variety? Okay. So, no, it's working. Obviously, models of choice and uncertainty play a crucial role in every field of economics. It's hard to think of any model that's more central. And the foundations of axiomatic theory of choice under uncertainty were established a long time ago by greats like Ramsey, von Neumann and Morgenstern, and Savage. And at the time, I think they must really have been like an earthquake in economics, because from some very plausible seeming axioms, they were able to get a really remarkable result, which was that rational behavior under uncertainty had to take a very, very special form, one in which individuals acted as if they were maximizing expected value of a utility function. In particular, this means that the probabilities enter linearly in the objective function. And because these claims were so striking and so strong, people spent a very long time, in fact, the next few decades, trying to prove that they were wrong. And most of this empirical research took the form of experiments, or in some cases surveys, in which people were trying to show that these axioms on which the theory relied were in fact violated in practice. And one of the tools for this kind of experiment was the so-called Marshak-Machina probability triangle. Let me just introduce you to it if you haven't seen it before. So here's a triangle where every point in this triangle represents a probability distribution over three outcomes. There's a high outcome, a middle outcome, and a low outcome. And these three outcomes, of course, occur with different probabilities, and each of these probabilities can be represented by a point in this space. Now, the important thing about the expected utility theory is that it implies that the indifference curves are going to be linear. That is, the probabilities, the probability distributions that are going to be equally satisfactory to any subject are going to form straight lines. And that's just because expected utility is linear in the probabilities. So how do you test this theory? Well, you do it by, first of all, asking people to choose between a pair of lotteries, say A and B, and then to choose between another pair, C and D, where the line segment, AB, is going to be parallel to the segment, CD. And because of the linear parallel nature of these indifference curves, if somebody prefers B to A, he should also prefer D to C. And if you get the opposite ranking, then you're going to have a contradiction of one of the axioms of expected utility theory. So, as I said, these tests routinely violated one or more of the axioms of the expected utility theory. And these empirical violations, of course, encouraged people to come up with a variety of other sorts of theories of decisions under uncertainty. And each of those could equally well be tested by some set of options, choices in the Marshak-Machina probability triangle. So I want to tell you now about a new experimental design and then suggest that this might have some advantages over the traditional experiments. You can think of this design as asking somebody to perform the sort of decision that's very commonly taught to people in intermediate micro, or maybe even in principles, where you have a consumer who has to choose between two goods subject to a budget constraint. But in this case, I'm going to assume that there's some finite number of states of nature representing uncertainty. And for each of those states, there's going to be an arrow security that pays $1 if that state occurs and nothing otherwise. And the decision problem is to choose a bundle of these arrow securities, or portfolio, to maximize your preferences subject to a budget constraint. So in other words, we present somebody with a budget set consisting of portfolios and ask them to choose the portfolio they most prefer. And this procedure is repeated 50 times with randomly generated budget sets. Prices are IID. And at the end of the experiment, we choose a single decision at random, and the subject gets rewarded based on his choice for that particular decision. The reason that we don't want to give them, say, the sum or the average of the payoffs for all of their decisions is because then, since these are independent choices, the law of large numbers would get rid of most of the risk, so it wouldn't genuinely be decision under uncertainty. So this problem can be presented graphically. If there were only two states and two arrow securities, you'd see a picture like this. So there's an x-axis, and the numbers along there represent the number of dollars that you want to have in your X account. So if the state of nature turns out to be X, you're going to get that amount of money. And the other axis, the y-axis, measures the dollars that you'd get in the Y state. And if that state occurs, then that's the amount of money you'd get. And this budget line represents all of the possible efficient choices that you could make. So people see this particular line, which is just one of many budget sets that are offered, and they go to the point that they prefer on this budget line, and they point and click, and that's their choice. And we can do the same thing with three states, here X, Y, and Z, and here we have to represent this three-dimensional budget plane, but the principle is exactly the same. Okay, so that's essentially the kind of experiment we're doing. We're presenting somebody with a lot of different choices, and it turns out that this is very efficient. They can complete these choices very, very quickly, and we can get a large amount of data in a relatively short time. And that's important in experimental economics because if people get tired or bored or frustrated, it's going to affect their behavior. So to be able to extract this information at little cost to the subject is really important. Okay. So what are the advantages of this method? Well, one is, as I've just said, that the graphical interface allows us to collect a rich data set at the level of the individual. And why is that important? I mean, apart from the fact that more data is always good, a large number of these studies depend on getting a small amount of data for each individual and then pooling the data across a number of subjects. But of course, if subjects have very different preferences, that's not a good procedure. So we want to estimate people's preferences at the individual level using only data for that individual. And from that point of view, this is a great advantage. The choice of a portfolio subject to a budget constraint provides a lot more information than preferences that a binary choice would. And this is because we know that there's a large number of things that this guy could have chosen. And the fact that he hasn't chosen them tells us a lot about his preferences. It allows us to eliminate a large number of possible indifference curves that might represent his choices. It also means, of course, that we can apply the classical tools of demand theory to analyze the data, and those turn out to be quite powerful. The fact that we can produce a large number of different decisions over time and that these are randomly generated means that we're observing the preferences for a representative sample of decision problems rather than a small number of carefully selected parameters. And it means that they're representative too in the sense that they represent the kind of problem that we're interested in, namely portfolio choice or consumer choice, rather than some rather extreme binary choice problem. And finally, this is a little bit more subtle, and perhaps I haven't expressed it in quite the right way, but we can test the ability of the theory to account for the data. We can ask whether a particular theory really fits the data, rather than simply assuming the theory in order to falsify it. So what happens in many experimental studies is that people say, let's take the theory as given in a very precise sense that we won't allow for any mistakes, we won't allow for noise, it's got to hold exactly or not at all, and then let's ask whether the assumptions of the theory are satisfied, and of course typically they're not. But what you don't find from that sort of exercise is whether the theory is approximately correct or how important the violations are and so on. So that's the sense in which we think that this approach of generating a rich data set and then applying the tools of, well, structural estimation or some other statistical technique are actually preferable. Okay, so the first thing we might do, and I think I'll try to skip over this quickly because this isn't the most exciting part of the work, although one of my colleagues thinks it is the most exciting part, is just to show how you could use revealed preference theory on this data. So, we've got a whole set of decision problems which we've observed for a single individual. This tells us the prices at which he was able to trade and the portfolio he chose. And what we're interested in, first of all, is whether there's any preferences, any utility function that would generate the observed behavior. And it turns out that there is a very simple criterion, simple to check in principle, which says that if the general axiom of revealed preference is satisfied, there does exist such a preference ordering. So a portfolio is directly revealed preferred to a portfolio xj, roughly speaking, if xi is chosen when xj was in the budget set. And then the indirect revealed preference relation is just the transitive extension of that direct relation. So the generalized axiom of revealed preference says that if xi is indirectly revealed preferred to xj, then xj is not strictly directly revealed preferred. And GARP is tied to utility representation through this theorem of Afriat, which tells us that if the data satisfy GARP, if and only if the data satisfy GARP, there exists a well-behaved utility function that will generate the same data. In other words, we know that there exist preferences that the maximization of which would have generated exactly these choices. And this is an exact result. It's not an approximate or statistical result. So it's really quite striking. Now, of course, because either GARP is satisfied or it's not, we expect people in the heat of an experiment when they're trembling with nerves to make at least one mistake. So it's a bit unreasonable to ask them to satisfy GARP exactly. So people have suggested various indexes which would measure the extent of any GARP violations. So we can get a continuous measure of how close people are to satisfying GARP. And one of these, there are several others, is Afriat's critical cost efficiency index, which is the amount by which each budget constraint must be relaxed in order to remove all violations of GARP. So the best way to explain this is to show you a picture. So here we have a violation of GARP because X is chosen when Y was available, but then, Y is chosen when X is chosen when Y was available, but then we turn around and choose Y when X is available. So X is directly revealed preferred to Y, and Y is directly revealed preferred to X. But if we were to take away some of the income when the person was choosing Y, then we could find that there was no violation. And the CCEI tells you the uniform minimum deviation or reduction in income you need in order to remove all of these violations. Okay. So this is something that we can compute. The trouble is that, of course, it just gives you a number and it doesn't give you a measure of closeness. So what we've done, and there is no theory really to tell us what a good number is, what we've done is do some rather extensive simulations of choices by random individuals and then use that as a standard by which to calibrate the measures that we get from the human subjects. I think I'll just skip over this discussion that tells you how we did it. This picture shows you distributions of the CCEI, which measures how close you are to satisfying GARP, where 1 is satisfying it perfectly, 0 is satisfying it not at all. And these densities correspond to this different values of this parameter gamma, which tells you, roughly speaking, how much weight you're putting on your true preferences and how much randomness there is in your choice. So if gamma is equal to 1/4, then there's a lot of randomness. If gamma is equal to 5, there's very little. And you can see as gamma varies, you're going to get more and more readings which are very close to 1. So that's not terribly surprising. It's really just indicating how this method works. What we wanted to do was choose what seemed like a reasonable value of gamma, which allowed for a fair amount of randomness, and then see how this compared to our real subjects. I'm going to skip over this bit too. So here we see two distributions of CCEI scores, and the light gray are the random subjects. These were 25,000 randomly generated individuals who made the same 50 decisions from random budget sets as the human subjects did. And you see that their CCI scores are not too high, and in fact, nobody out of those 25,000 got a perfect score. Whereas for the human subjects, which are the black bars, you see that quite a few did get perfect scores, and that generally the distribution lies to the right. So this, I think, is a fairly reasonable test whether GARP is satisfied or not. There are others. For example, you can look at the maximum set, the cardinality of the maximum set that satisfies GARP perfectly. In some cases, that would be 50 decisions. In others, it would be 48, 49, and so on. But by almost any measure we look at, the satisfaction of GARP by this measure is very, very high. Now, what does this tell us? It tells us that there is a utility function that will explain the choices of each of these individuals with a few exceptions for each case. And hence that they are substantively rational, that we can explain their behavior, and to do that without assuming any mistakes or randomness. So from one point of view, that's great news. It tells us that the standard economic model, maximizing preferences, works. Ultimately, that may not be what we choose to do, but at least we know that it can be done. It also tells us that if we want to choose a different route, we've got to admit that we've got two theories that are observationally equivalent, substantive rationality and something else, which turns out to be procedural rationality. Yes?
The randomly generated results, how exactly are they generated? This is when you say random subjects, you mean
Okay,
computer,
so
you're talking letting the computer be the subject?
And so these are just computers making choices, and one method, which is called Bronner's test, is to assume that they just choose completely randomly from a uniform distribution on the budget constraint. That would be completely random. The other would use some kind of use a true utility function with some kind of logistic error on it, and that says, depending on the parameter gamma you choose, it's going to be somewhat random, but also somewhat influenced by its relative payoff. So you can get anything between completely random and maximizing utility. And then we just plug in something like, I think it was a power utility function of some sort for the purposes of this exercise. This is just another picture where we had a three-dimensional problem. And we see that the results are even more striking. There's almost no overlap between the random subjects and the human subjects. Okay.
You have me in your data set, we could change that.
You would only have been one person, Larry. I mean, there are a large number of subjects. So, having established that this is very consistent with substantive rationality, let's take a look at individual behavior. And here we see some marked regularities in the behavior of individual subjects. We also see a lot of heterogeneity across subjects. And going back to the point I made earlier, it doesn't really make sense to pool data and when you have heterogeneous preferences. And from what we see, these preferences are very heterogeneous. But whatever is going on, in many cases, it's not consistent with expected utility. for reasons that I'll explain in a minute. There are certain kinds of behavior which are consistent with expected utility for certain parameters, but not all of the behaviors exhibited by a single individual seem to be consistent. So I'll just give you a few pictures to make that clear, or at least I hope it'll make it clear. So this is the behavior of a subject in one of these two-dimensional experiments. Just look at the top diagram. The others don't matter for now. So there we see demand for security 1 on the horizontal axis, demand for security 2 on the vertical axis. And all of these points in the scatter diagram lie along the 45-degree line. So what's this guy doing? He's choosing the same amount of dollars in state 1 as he gets in state 2. So he's not facing any uncertainty. Now, this would be a perfectly sensible thing for someone to do if you're infinitely risk averse. And that's certainly a limit case of expected utility maximization. So just hold on to that and let's look at somebody else. So here's somebody who's doing what we call boundary behavior. He goes to a minimum. It happens not to be 0 in this case, but it could be 0, and for many people it is. But he goes to a minimum, presumably depending on whether the price of security 1 is higher or lower than the price of security 2. We can't see the prices at which he makes these choices, but if we did look at the prices, we'd see that in fact he is choosing the security that maximizes his expected return, and he maximizes that choice subject to this boundary constraint. So this is the kind of behavior that would be consistent with risk-neutral choice, subject to some minimum quantity of each. And again, that's consistent with expected utility behavior. Here's somebody who's smoothly responsive to prices. He's exploiting the risk-return trade-off. His behavior is very regular, notice, but otherwise there's nothing much to be said about it. Look at this guy. So some of the time he's on the diagonal. In other words, he's behaving as if he's infinitely risk-averse. The rest of the time he's on the boundary as if he were risk-neutral. And if you look at the lower left-hand panel, what we have on the horizontal axis are the relative prices. It's the log price ratio. And the token share, that is the ratio of x1 to x1 plus x2, is on the vertical axis. So you see that when the price of security 1 is less than the price of security 2, he tends to put everything in security 1, as if he were risk neutral. And similarly, when the price of security 2 is less than the price of security 1, he puts everything in security 2. So he's really behaving like he's risk neutral. But in the middle, when the prices are nearly equal, then he becomes infinitely risk averse. Now, this is not consistent with expected utility behavior, mainly because this kind of behavior implies that there's a kink at the diagonal, and there just can't be with expected utility. Expected utility has to be locally smooth at the diagonal. So there's something wrong here if we're expected utility believers. There's some other cases I can go through, but I'll just skip it. Well, there are some theories around that justify this kink at the diagonal. And one of them, to pick one from several, is Farouk Ghoul's theory of disappointment aversion, but it could also be interpreted as a form of loss aversion. And this says basically that, you know, if you chose x1 greater than x2, so you're saying I want more dollars in state 1 than in state 2, and then state 2 occurs, you're really going to wish that you'd, in fact, reverse that that ordering, and you'd ask for more in the state that actually occurred. And you know, his theory, he provides some axioms that indicate that in the two-state case, the utility function over portfolios has to take the following form. you see here that you're putting some number alpha, which would be greater than or equal to 1, in front of one of these utility numbers, and then you take the min over which one it's in front of. So that basically says if you ask for less x1 than x2, you're going to put this extra weight on the outcome, x1. And that basically reflects the fact that you're disappointed if you ask for more in state 1 and then it doesn't happen. So let me just give you a picture of the preferences that correspond to that. This is the, I don't even have a laser pointer here, but you can see there the gray area is the budget set, and that kink line that's just tangent at the 45-degree line is the indifference curve. Right? And the kink at the point where x1 equals x2 reflects the fact that when x1 is greater than x2, you're going to put the alpha on the smaller number, and vice versa when the ordering is reversed. So that gives you the kink. And then imagine that you're looking at prices which are tangent to those indifference curves. When the budget line is flat, you're going to be choosing an extreme point on the horizontal axis. When it's very steep, you'll choose an extreme point on the vertical axis. And when it's in between, you'll have a tangency at the 45-degree line. So it does give that behavior of heaping on the diagonal that we saw. And we can estimate this, this kind of preference function. And it turns out that about half of the subjects exhibit significant loss aversion. I mean, statistically significant loss aversion. The others are consistent with expected utility maximization. If we look at the estimated parameters using a power utility function as our von Neumann-Morgenstern utility function, then this is what we see. Rho, the risk aversion, is on the vertical axis, and alpha, the measure of loss or disappointment aversion, is on the horizontal axis. So you see there are a lot of people with largely low levels of risk aversion, but have varying levels of disappointment aversion. And there are very few people who have very high risk aversion, and they tend to have very little loss aversion. I'm speaking loosely here because rho is the parameter that we normally associate with risk aversion. But in fact, in this case, it's not, because risk aversion is measured by your attitude towards risk and your willingness to take certain bets, or the risk premium you require in order to take some risk. This is actually a function of both rho and alpha. And that, I think, is why we're seeing these points that are close to the two axes. To some extent, they're substitutes for one another. Okay. So let me briefly switch to some discussion of ambiguity aversion. I'm not going to spend too much time on this because I end up having less time, I think, under your rules than I expected. And I want to get to the bounded rationality part at the end without keeping you from the castle any longer than necessary. So I'll try to go through this somewhat quickly because this is, in a way, just another application of the sort of ideas that I talked about in the risk experiment. So what is ambiguity aversion? Well, basically this idea comes from an insight of Daniel Ellsberg, and he proposed the following thought experiment. He didn't actually carry out this experiment, but when people did the experiment in practice, it turned out that he was absolutely right in what he'd speculated. So suppose there are two urns. One contains equal numbers of red and white balls, and the other contains an unknown number of red balls and an unknown number of white balls. And then we're going to present people with gambles that take the following form. You get K dollars if a particular color of ball is drawn, and nothing if the other one is. So one might be, if a red ball is drawn from this urn, you'll get K dollars, and if a white ball is drawn, you get nothing. And then we ask people about their preferences between gambles of this form where one of them has the ball chosen from the urn, which is unambiguous, that is where you know the probabilities of red and white, and the other is from the urn, which is ambiguous, at least the probability is unknown. Now, if a subject prefers, say, choice of the red ball from the unambiguous urn to the red from the ambiguous urn, then expected utility implies that he must prefer white from the ambiguous urn to white from the unambiguous urn. And that's because his first choice implies that he thinks red is more probable in the unambiguous urn than in the red urn. That is, it's higher than 50%, and therefore, if he's given a choice between white from the ambiguous urn and white from the unambiguous urn, he should choose white from the unambiguous urn. Okay, so this turns on the fact that subjective expected utility implicitly assumes that whatever your preferences are, they're based on a particular probability. So even if you don't know the probability, you're going to act as if you had a certain estimate of the probability of a red ball from the unknown urn. And this prediction is generally violated in many experiments. So here's an ambiguity experiment that we could do, not with urns, but with this portfolio choice problem. We suppose there are 3 states, 2 of which have ambiguous probabilities. And say state 2 is the probability 1/3. And for the other 2 states, we just know that the sum of their probabilities is 2/3. In other respects, the decision problem is identical to what we went through before, and it's carried out in exactly the same way. But notice that unlike in the urn experiments, in this case, you can avoid ambiguity simply by making sure that x1 equals x3. Then you're not ambiguous about anything. You know you get x1 equals x3 with probability 2/3, and you get some value of x2 with probability 1/3. Okay. So there are a whole bunch of theories of ambiguity. They basically fall into 2 groups. There are some which have kinks on the diagonal, and then there are others that don't, that are smooth. I won't say anything more about it to save time. So we estimated a number of these. The one that I'm going to be interested in is the so-called alpha MEU model. It takes the following form. There's a typo in this slide, unfortunately. The first term should be 1/3 u of x2. So that's the term corresponding to the unambiguous state. It should be x2. And there you just use the true probability 1/3, multiply it by the utility you get from having x2 if state 2 occurs. Then you apply probability 2/3 to the states 1 and 3. But for some number alpha greater than or equal to 1/2, you apply alpha to the minimum of x1 and x3. Now this is rather like the operation we perform with the disappointment version model, but it comes about for quite different reasons. Essentially what you're doing is imagining that the worst state, the state in which you're going to get the lower outcome, will have a higher probability. So you're manipulating the probabilities. Oh, thank you. Manipulating the probabilities according to whether you get the low outcome in that state or the high outcome. There's a kind of pessimism involved in your beliefs. But notice that if x1 suddenly becomes greater than x3, then you're going to put the alpha at on the other state. So this formulation has as special cases subjective expected utility and also something called min-max expected utility. But when alpha is greater than 1/2, there's clearly going to be a kink at the diagonal where x1 is equal to x3. And I've already noted the similarity to loss or disappointment aversion. Now, again, we find that there's this heaping on the diagonal which suggests ambiguity aversion. But unfortunately, it also occurs on the diagonals x1 equals x2 and x2 equals x3. In other words, it seems like there's some loss or disappointment aversion mixed in with the ambiguity aversion. And the only way to to figure out how much ambiguity aversion there is to estimate a model that explicitly allows for loss and disappointment aversion in addition to ambiguity aversion. So that's what we do. And we do it in a very straightforward way. We essentially start with a theory of rank-dependent utility, which I think I'm going to skip over so that there'll be time for questions. And then marry this with the alpha MEU idea that we used before. And that's going to give us formulations of the utility function that look like this in 3 different cases, depending on whether the unambiguous outcome is less than both the ambiguous outcomes, or is in the middle, or is greater than both the ambiguous outcomes. And then we've estimated this. It turns out it has 4 independent parameters because there are various continuity requirements across these different regimes which impose consistency on these parameters. We can estimate that, but it's rather hard to interpret. So we've also estimated a simpler 2-parameter model. And here's the result. So this will tell you exactly how many people are ambiguity averse, how many are loss averse or disappointment averse, and how many both. So it seems like 60% of the people are ambiguity neutral and loss neutral. In other words, there's 60% of these guys who are consistent with subjective expected utility. But there are significant numbers who are averse to either loss, disappointment aversion, or ambiguity, or both. So 17% are ambiguity averse, but neutral to loss. 18% are neutral to ambiguity, but averse to loss or disappointment. And there is but 5% who are averse to both. So in the end, the number who are averse to ambiguity isn't that great. It's only 0.2, which is much less than you'd guess from the EARN experiments. There's somewhat more who are averse to loss, but a surprisingly large number are neutral with respect to both. So that's just a further illustration of how we can use these methods. Okay, so how do subjects come to make decisions that are consistent with an underlying preference ordering? So very roughly speaking, we think that boundedly rational individuals use heuristics in their attempt to maximize an underlying preference ordering. So there's an underlying ordering which represents your true preferences, and then there are various methods that you use to achieve the maximum of that underlying preference ordering. The underlying preferences, we're going to assume for simplicity and because we want to minimize the assumptions we have to make, have the standard EU representation, even though revealed preferences appear to be non-EU. And according to this approach, the reason that we see these weird kinds of behavior, and some which are much weirder than what you've seen already, is because they're using heuristics. They're trying to simplify the problem. And I'll give you a kind of sketch for an excuse for a theory later on that might help interpret this. But we don't really have a fully worked out theory of how this works. So one thing you can do if you actually want to estimate a model based on this and extract preferences is to use type mixture model. And this is something that we have done. We thought that the results were reasonable, but they were somewhat mixed. So this is work in progress. In this case, a subject chooses among a fixed set of types or heuristics in order to approximate behavior that's optimal for his underlying preferences. And consistent behavior then requires subjects to choose among heuristics in a consistent manner, as well as behaving consistently in applying a given heuristic. So we can estimate the probabilities of individuals choosing different heuristics in particular situations, that is for particular budget sets, and at the same time estimate their underlying true preferences. But the theory of revealed preference doesn't apply here because we're assuming that what drives these preferences is both the underlying true preferences and some heuristics. So we get very reasonable estimates for risk aversion, certainly consistent with data from other experiments and other studies. And it does have some significant explanatory power, but I'm not entirely happy with it for a number of technical reasons. So what are these heuristics that people are using? Well, we identify a finite number of stylized behaviors which are difficult to explain, certainly if people are using a mixture of them. We call these basic behaviors archetypes, and then we call the mixture of these behaviors polytypes. So the archetypes account for a large proportion of the data set and play a role in the behavior of most subjects. Let's look at that. Here are the first two of these archetypes. The center, in the three-dimensional case, corresponds to choosing exactly the same demand for the arrow securities in each of the states. Here we see an individual subject who did exactly that in every one of 50 choices. The vertex is a guy who chooses the vertex of this triangle, and that corresponds to putting all your money on one state, as if you were risk neutral. The centroid is weird. He's like the center, but now what we're showing you here are the budget shares rather than the token shares of choices. So this means he's spending equal amounts of his initial wealth on each of these securities, but different amounts of the arrow securities depending on the prices. Now this is a really weird choice, and this is actual data you're looking at here, because first of all, there's no reason to think that these subjects know anything about the Cobb-Douglas utility function or have logarithmic von Neumann-Morgenstern utility functions. And even if they did, how would they implement such a choice? It's not easy to do. Well, it turns out there's a very simple geometric heuristic that will identify exactly the Cobb-Douglas choice in the budget set. And so it's not the case that people are actually maximizing Cobb-Douglas function, according to our interpretation. Rather, they're using this simple geometric heuristic for reasons known only to themselves. This might be a clone of Larry, I guess. Because you're fond of the Cobb-Douglas utility function, I know, or maybe it's the Cobb-Douglas production function.
I recognize myself.
Yeah, okay. The edge, well, this is the heuristic where you actually choose points on the edge of this triangle. What it means is you're investing 0 in one of the arrow securities and then dividing your wealth between the other two arrow securities. Now, this is not the same as being risk neutral. I mean, it is conceivable to be risk neutral and make these choices if you had just the right prices. But typically, a risk neutral person would be choosing points at the vertex, not here. So these people, for some reason, just simplify the problem by choosing a 0 quantity of one security and then having an interior choice, and hence a trade-off between the other two. The bisector, these are people who equalize quantities of x1 and x2, or x2 and x3, or x1 and x3, and then vary the amount of the third. Here's a case where somebody is using both the center and the bisector. I mean, it's fair enough to use one of them, but to have them both, that's a bit odd. Here's the edge and bisector, or the center, vertex, and edge, and so on. So we get these mixtures of these archetypes, and we call those the polytypes. Now remember, all of these people are rational, substantively rational. So we could find a utility function that would rationalize these choices. But the question is, do you find that convincing, and is there another explanation that might be somewhat more interesting? There are some more examples. We'll skip some of these. This is just an illustration of the distribution of these different archetypes in the choices by the different individuals. Now, of course, nobody hits these things exactly, and in fact, even though this is done on a graphical interface, there is a finite confidence with which they can move the mouse. So we have to allow for some little neighborhood around the exact definition of these archetypes in order to be able to observe them. So here we use a half-token confidence interval, and this is the distribution of the different archetypes we find. If we were to expand it, say to have a one-token confidence interval, you see that the fraction of choices that fall into one of these categories is very high, and we can easily do random simulations and figure out if people were actually maximizing some expected utility function, but with some error, how likely is it that they would make choices that lay in these sets? Much, much less than this. It almost never happens. And in fact, the ratio of the proportions gets bigger. That is, the difference between random individuals and the actual subjects gets bigger as you let the confidence interval get smaller, which is sort of interesting. Yeah. You got another question?
Do you have one more question?
Yeah, sure.
So your subjects are actually being confronted with these triangles,
Yeah.
and they're being paid off exactly. I mean, I could see myself doodling,
That's because you're so rich, Larry. For these people, I mean, the average payoff was like $50 plus their show-up fee, and these were students plus low-paid staff at Berkeley. So I think it was probably enough to keep their attention. But think of the consistency. I mean, if you were just doodling, wouldn't you think you'd make some GARP violations along the way? I mean, they're so consistent.
I see. So well, most are consistent.
Some are not, but I mean, it's like, I forget the exact proportions, but most of them are very consistent.
This is dangerous. I'm going to turn this off.
Are there any journalists here? But you've got nothing to worry about, Larry. You're among friends.
So tell me again exactly. They're sitting there and they get for the $50. What happens exactly? What are they supposed to do to get the $50?
They make a choice.
Yep.
I think, in fact, they make 50 choices. Then one of those decisions is chosen at random by the computer. Okay. The state of nature is determined randomly. And then they get the payoff that they chose for that decision.
Oh, I see. Okay. Got it.
So it depends entirely on what they chose. But it could be a reasonable amount of money. Not a huge amount, but...
And if they blow it, they walk away with nothing.
Yeah, I mean, it depends on their choice. You see, if they could have chosen the same amount of money in each state, in which case they're not bearing any risk at all. I mean, except that there's some uncertainty about where that intersection would be. But yeah, if they went for broke and invested everything in one state and the other state came up, then they get nothing. Okay, so this is the pièce de résistance. It's a pilot. It's not really a paper yet, but we did some experiments I mean, we were concerned about the fact that these guys are as near as we can make it with some allowance for small errors. They're substantively rational. I mean, we can find a well-behaved utility function that accounts for their behavior. So it's impossible to say that that's definitely wrong, no matter how much we believe that there may be heuristics in play here. So we thought, well, how can we, really get a smoking gun? That's what Vince told us we needed if we were ever going to convince the profession. So one of the things, we've got other ideas, probably better ideas, but one of the things that was easy to do and quick was, well, let's have people do, say, three-dimensional decision problems and two-dimensional decision problems. The three-dimensional is probably harder than the two-dimensional. Maybe we'll see some difference there. And if it's heuristics that are in play, perhaps we'll see some difference. So let me show you some examples from the experiments we ran. Again, people did 50 choices, the same protocol as before. So here's a guy who's first making choices in the three-acid experiment, and you see that most of his choices are in the bisector. So he's choosing to put x1 equal to x2 or x2 equal to x3, and so on. Now this could be he just has a really kinky utility function, or it could be that he's simplifying his decision problem by saying, I'm not going to bother with variation between x1 and x2 because their prices are rather similar. I'll just put those two equal, and then I'll vary the amount of the third security. But look what he does when he's doing the two-dimensional experiment. He does something completely different. It's impossible to explain this behavior with these preferences. So here's somebody, again, who goes for the bisector in the 3D choice problem and does something a bit weird, a combination of boundary and some smooth trade-offs in the 2D. I think what's also going on here is, you notice there's some heaping on the tens, which again is a form of heuristic. But I don't want to emphasize, I mean, that's not important here. The fact is that what's going on here, I mean, if this was just kinky preferences, then here you'd expect all of these things to line up on the diagonal. Or at best, he'd be switching between the diagonal and the boundary, but he doesn't. Okay, so here's somebody who's on the edge in the 3D, which means that he's not behaving like a risk-neutral guy, although presumably he's not too risk-averse. But then when he goes to the 2D, he reverts to what looks like risk-neutral behavior, purely risk-neutral behavior. I don't know if I have another. Oh, yeah. So here's somebody who's going for the center as if he's really, really risk-averse in the 3D. And then when he goes to the 2D, he's sometimes on the diagonal, which is consistent here. But then other times, he's really close to the boundary. So again, these things don't. I mean, to get a really precise test, of course, you've got to take into account the fact that he's facing different prices in the two experiments, and you've got to be more precise. But I think this is quite suggestive that what's going on has something to do with heuristics. Let's get out of this. So I promised you a sketch of an excuse for a theory, and this is it. So how are we going to understand this? Think of this as a deterministic version of the type mixture model I referred to earlier. Suppose that, again, we've got a certain number of states of nature and equal number of arrow securities, and we're trying to maximize some underlying utility function, which in this case we'll assume is expected utility, but it doesn't have to be, subject to the budget constraint and to the idea that you have to choose from one of these archetypes, act as if you're risk neutral or infinitely risk averse, or you have a kink on a particular diagonal. The only restriction we have to make is that A is a pointed cone, which is something that would be satisfied if it were a union of all the archetypes I talked about before, except for the centroid. The centroid depends on prices, so we can't allow for that. Okay. So we're essentially just saying your budget set is smaller than you thought because in addition to having to satisfy the budget constraint, you've got to choose from one of these odd types of behavior. And then what we can show is that there will be, first of all, that this behavior is going to satisfy GARP. It will be consistent. Just imposing these constraints isn't going to in any way violate GARP. But also there's going to exist a utility function such that if you're maximizing over the entire budget set, you're going to get the same point as you would if you maximize your original preferences over the constrained set. So that you would get substantive rationality according to this artificial utility function. Right? So that's how we would sort of rationalize the two different types of observationally equivalent behavior, but still leave a role for these archetypes. But as I said, this is not really a theory. It's really just a metaphor for a theory. Do I want to go through these pictures? If I'm going to leave time for questions, perhaps I'll stop now. Okay, let me stop. So that's enough. Let's open up the debate.
If you do have questions, we have microphones. The mics are for the video only, just yeah.
Yeah.
Hi, Douglas.
Hi, Monty.
I was very impressed by reading Don O'Reilly's book on Predictably Irrational, and one of the compelling stories in his book is that the independence of irrelevant alternatives is violated in some very simple choices. Yours has lots of possible alternatives, and it's somewhat confusing. I'm just wondering what your thoughts are on that perspective on the reason people are making very different choices when you add an irrelevant alternative.
Yeah, I don't think these people are confused. I mean, the fact that their choices are so consistent is really remarkable. I mean, it's a very low probability event if you thought that they were being in any sort of casual sense irrational, which I think is what Dan Ariely is saying. I mean, yeah. So, I mean, yeah, maybe you have a more sort of concrete question about how they may be confused by having many choices.
Well, I say confused is probably because I'm not a precise decision theorist. I would say they make very different choices when you offer them some alternative which they're never going to choose or very rarely choose. That's the key one, the example being the three options for the economist, which are in the first chapter.
Yeah. Well, Dan is very good at drumming up these results, but I think that in fact, in our experience, giving people a more complex choice often leads to simpler and more consistent behavior, just because they focus on what's important and ignore everything else. So, it may be that if you have a small set of alternatives, irrelevant alternatives matter, but if you actually have a huge set of alternatives, you're just not going to pay any attention to most of them. I mean, I haven't read Dan's book, and I don't think I ever will, so I can't really address the economist's choice. But
yeah, maybe this is actually sort of similar, but I was struck that they seemed so consistent when you had two choices and consistent when they had three choices, but you could find these inconsistencies when you were sort of comparing the same people making two choices and three choices. So
yeah,
is there a way to write something like a GARP statement or that could be violated in compare? I mean, it struck me that at the beginning when you sort of talked about these paradoxes or GARP, it was this comparison with the same number of choices but for different prices. But do you think there's a way to make progress on this point about when you introduce the alternative, a third alternative? Maybe this is similar to what Randy was saying, that then there's things that we can say that are going to violate our old theories.
Yeah, so, I mean, these people continue to be consistent in each of the decision problems as they satisfy GARP, or very close to it. It's hard, I mean, I guess you could think of...
I agree they satisfy GARP. Didn't something get violated when they switched from 2 to 3?
Well, I mean, we treat them as distinct decision problems, and GARP doesn't really apply to that.
Right.
Now, I guess you could think of the two-dimensional case as being like a special case of the...
Yeah, with price equal to infinity.
Yeah, with a price equal to infinity, and then apply GARP and see what you get there. Yeah, we haven't done that, and I don't know what would happen.
It just looked like you did get the inconsistency when you compared the same people making two choices or three choices, and I wonder if that's some direction that could be, that's worth.
It probably could be, and that's something we should look at, definitely. Because they don't look like the same preferences,
Yeah.
but again, you have to worry about the prices they were facing.
Sure.
Have you given any thought to how the nature of presenting this as a graphic is could influence the framing of this? Like, suppose you gave them half the problems where they'd have to do this numerically, like give you three prices and you type in some admissible quantities and then compare that to how they would do in your standard experiment with the graphics.
Yeah, we have thought about that because I mean, one thing that a lot of people have said is, well, it's all being driven by the frame, and therefore we shouldn't pay attention to us. I think in a way that's a non sequitur. Of course, if you're going to talk about heuristics at all, you have to accept that the frame matters, because something that simplifies the problem when the data is presented in one way is not going to help when it's presented in a different way, or where you have to enter your decision in a different way. So, yeah, we shouldn't expect this to be robust to changes. And indeed, what we saw with the 2D and 3D problems was their behavior wasn't robust to change, which seems like a relatively simple change in the nature of the problem, even though in some sense it was being presented in the same way. So, yes, we've thought about it. We think that the frame matters. Sometimes we've had discussions with people who are invested in the Earn style of experiment, and it's natural they want to argue for its advantages. And I guess we don't want to claim that that's no good, but it's a valid way of doing the experiment. But I don't see why this should be any less valid. And we think that to the extent that it allows us to collect a lot of data very quickly, and people seem to behave very consistently, and not just consistently in the sense of satisfying GARP, but they behave in ways that make sense, that seem reasonable. It makes it hard to believe that this is actually distorting their preferences or somehow contaminating the data. But obviously, more experiments have to be done. And one interesting question is, well, what happens if we give people an Earn experiment and then this experiment? How do things change across the two? But of course, if you do believe that they're going to behave differently, and if that bothers you, you have a choice of either abandoning the notion that people have stable preferences, or what's the alternative? I don't know. Yeah.
I think simpler. Have you tried to just distort the axes? Okay, so stretch one axis, stretch another axis.
Yeah.
See
Now
what
we haven't tried distorting them. What we are thinking about is adding noise. I mean, there's a series of experiments planned where we're going to add a little bit of noise in the payoffs, which is going to essentially smooth out the kink. Or I mean, if the preferences really are substantive, rational preferences, but with kinks, adding a little bit of noise should smooth out that kink. And so that's one thing we're going to try. But yeah, we'll think about distorting the.
Understand whether these people are really geometers or something else. Right?
Yeah, that's true. That's true.
So you're finding most people are consistent if you have a given kind of problem, but if you change problems, the people that are consistent, let's say in one problem, could look kind of like their preferences change dramatically across the two problems, right?
Yeah,
So-
it's not a large number in this experiment. I mean, I only showed you a few. We cherry picked the ones that were dramatic and might get you interested. But there are a lot of people who, always choose the diagonal, and they do that however many assets there are, or there are people who are always risk neutral.
So what is your bottom line? I mean, is this kind of, it seems like you're saying two things. One is you got a lot of wacky, crazy people out there, and then most of the people are our kind of people. Or, because you didn't put you left your I was waiting for the conclusion slide, but you kind of took it off. Where do you come down? Is this the end of economics, or is this?
Absolutely not. This is just the beginning. I guess there are a number of potential takeaways. One is, don't count out subjective expected utility just because some experimenters have shown that there are, what looked like kinks. Another is that you can't always rely on theory of revealed preference, because if people are procedurally rational, they're not revealing their true preferences. They're revealing some combination of their underlying preferences and then heuristics, which have been learned over a long time. And we also, of course, get this classification of people. Some people just look like expected utility from the get-go, and some people look like a smaller fraction than you might think from some experiments. They look like they have these non-standard preferences, but then those may be explained by heuristics. And when you put them in slightly different situations, like having a two-state versus a three-state model, some of those people are going to change their behavior, which seems to be more, unless you accept that people don't have stable preferences at all, that seems to be more easily explained by the use of heuristics.
Do you do any post-experiment interviews with these people? Like, yes, what they go,
No.
might be worth it to say.
Yeah, this is apparently a no-no in experimental
ask?
methodology. One of my co-authors has explained it to me that if you start asking them questions, then they'll anticipate that you're going to ask questions in the next experiment. And then you've tainted the pool, because they're going to be doing things to please you, or things that they can rationalize rather than their true behavior. So it's important not to talk to them. That's what they say.
So you had a certain number of subjects who behaved as if they were risk neutral, I think, and then others that behaved as if they were infinitely risk averse. And as I was watching that, I was thinking, this, even though we could rationalize their behavior with certain types of utility functions, this was also fairly weird. I couldn't remember the last time I've actually met a risk neutral person or an infinitely risk averse person.
Right. Yeah, but if the stakes aren't very high, it might be a. If the stakes aren't very high, it might be a reasonable approximation to what they're doing, to what their true preferences would indicate, and that's basically all we're saying.